Hello students, welcome to the class, and today we will be discussing the questions based on series and parallel combination of cells that we have discussed in the previous class. So we have to understand that here is a combination that is given and you have to find the equivalent cell. Find equivalent cell. That means you have to find the cell in this way. This is how much? E equivalent is equals to how much? And R equivalent is equals to how much? This is based on the series and parallel combination of our cells. So here you see, these two cells are in parallel, 10 volt and 4 volt are in parallel, and then it is in series with the 6 volt. So internal resistance is 2 ohm, 2 ohm, 2 ohm. Now in parallel what we have discussed? In parallel we have discussed E parallel is equals to 1 by is equals to E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2. This we have already discussed. So it is your, now here you see, this is your E1, this is your E2, and suppose this is your E3. In this situation, what we are observing, E2 is negative. So what we are getting? We are getting in this way E1 10 by 2. At the place of E2 we will place minus. So it is 4 by 2 by 1 by 2 plus 1 by 2. So in parallel series what we are getting? We are getting 5 minus 2 by 1, that is 3 volt. And what is R equivalent? R equivalent is your R1 into R2 by R1 plus R2. This is your R1, this is your R2. So what we are getting? 2 into 2 by 2 plus 2, that is 1 ohm. So what is our question? So next thing is there to understand, this can be replaced by this one. Now here you see, this voltage is high, so polarity will be of this cell. This polarity will be of this cell. This is negative, this is positive, so this polarity will be, this I have taken positive, so polarity will be of this cell. So what we are getting? We are getting 6 volt, 3 volt, 2 ohm and 2 ohm, A and B. So our result is what? Now these are in series, so result is what? E equivalent is equals to 6 volt, E1 minus E2, polarity is reversed, plus minus minus plus, so 6 volt minus 3 volt by 6 volt minus 3 volt, that is your 3 volt. And R equivalent will be 2 ohm plus 2 ohm, that is your 4 ohm. So what is here? Here the result will be, this will be 3 volt and this will be 4 ohm. So this is replacing, this is the equivalent of the combination of cells. This combination of cells can be replaced by this one. This thing should be clear in your mind. Only thing is that you have to keep in mind this formula, how it has come, that I have discussed in the previous video. So this thing has to be clarified, this formula has to be remembered, and then you can easily get the answer in this way. Now based on the series and parallel combination of cells only, we are discussing the next question, and the next question is in this format. In this format you are saying that there is a 2 volt battery and 2 ohm internal resistance, and 6 volt battery and 4 ohm internal resistance. This point is A, this point is B, and this point is C, and this point is B, and it is connected with this is the load resistor. This is connected with the load resistor, that is your 10 ohm. Now see, the polarity of the battery is different. So first of all, I would like to find and here the question is, you have to find VA minus VB. What is the potential difference between A and B, and what is the potential difference between VA and VC. Now here you see, as this battery is stronger, so the current will move in this direction. In this direction the current will move. So here we can take plus to minus, here we can take plus to minus, higher potential. Now in this situation, the current I will go in this direction, because this battery is stronger, so it will overpower this battery, which tries to give the current in this direction. So here you see E net, as the two cells are in series, so E net is 6 minus 2, opposite polarity is there. This is dominating, so I have taken this one, so it is your 6 minus 2, that is 4 volt. And R net will be, internal resistance net will be 2 ohm plus 4 ohm, these are in series, so it is 6 ohm. So I is equals to how much? I is equals to E net by R net plus R. This is the total resistance of the circuit, plus R. What is this R? This R is 10. So it is your 4 volt by 6 plus 10, that is 1 by 4, that is 0.25 ampere. This is the current that we have obtained. Now we will apply the Kirchhoff's law in the branch. So what I would like to tell you, from here to here I am moving, VA to VB. So see carefully, this is plus, this is minus. So VA, then there is decrease in potential, so minus 6 volt. Then further there is increase. So plus, increase means addition of body's potential, and decrease means subtraction of potential. So VA minus 6 volt plus increase, that is 0.25 I into R is your 4, that is equals to VB. So VA minus 6 volt, because it is decrease, plus to minus decrease, then there is minus to plus increase, so plus 0.25 into 4, that is equal to VB. So VA minus VB is equals to 6 minus 1, that is 5 volt. So VA minus VB we have calculated. One answer is here, this is one answer. And second, we have to find VA minus VC. Now if I move from here VA to VC, you see VA plus to minus, again decrease is there, so it is minus 2 volt, and then plus to minus, again decrease is there, so minus 2 into R into I, that is VC. So VA minus VC is equals to 2 volt plus 0.5 volt, that is 2.5 volt. So this is your answer. In this way we have solved this circuit, that in this situation the series combination of cells is there, but with opposite polarity. And this is the way I hope that you have understood this question, and this will be helpful in clarifying the concept that I have discussed in your series and parallel combination of cells. It will be helpful in understanding that concept, clarity of that concept. The examples are based directly on the text that I have discussed with you people. In the discussion of the problems related with series and parallel combination, we are discussing the next question. That next question is there: 4 identical cells each of 2 volt are joined in parallel, providing supply of current to an external resistance. This is your external resistance consisting 2 15 ohm resistors joined in parallel. This is your external resistance. External resistance. They are joined in parallel. This is load. And the terminal potential difference of the cells as read by an ideal voltmeter is 1.6 volt. Across this, the terminal potential difference is your 1.6 volt. This is the terminal potential difference from here to here. This is 1.6 volt. Calculate the internal resistance of each cell. of the cell. Identical cells are there. If I suppose R is the internal resistance of the cell, then as the cells are connected in parallel, so EMF of the circuit is your 2 volt and terminal potential difference is your 1.5 volt. 1.5 volt. 1.5 volt. If the terminal potential difference is 1.5 volt, then what we can take? We can take in this way that the equivalent resistance of this 15 ohm resistor can be written as 15 into 15 by 15 plus 15, R1 R2 by R1 plus R2. This will give you 7.5 volt. Now this formula I have discussed. This formula I have discussed in the theory discussion, that how this formula I have discussed. Try to understand. E is equals to V minus IR, and V is equals to E minus IR. So E minus V is equals to IR. So R is equals to E minus V by I. And what value of I we have calculated? No, this formula is not required. Here directly you can write I is equals to E minus V into R. It is V by R. So this is the formula, E minus V by V into R I am using here. So E is how much? 2. V is how much? 1.5 by V 1.5 into 7.5 is the R equivalent. So we are getting 15 by 8. Now 15 by 8, the internal resistance that we are getting, this is equivalent internal resistance of the parallel combination. And in parallel combination, 1 by R dash should be 1 by R plus 1 by R plus 1 by R plus 1 by R. So 1 by R dash should be equals to 4 by R. So R dash is equals to R by 4. This is the value that we are getting. So internal resistance of one cell, R is equals to 4 into R dash. So R dash is equals to R by 4 and R is equals to R dash into 4. That is 15 by 8 into 4. 15 by 8 we have got into 4. So 7.5 ohm. That means 7.5 ohm is the internal resistance of each cell. This thing should be clearly understood by you people. This is the way how we calculate the internal resistance in the given circuit. So this question is based on calculation of internal resistance. In continuation of discussion, we are trying to discuss the next question, and the next question says that 100 cells are arranged in rows of 50 cells in series and 2 rows in parallel. So 50 cells in series and 2 rows in parallel, row number 1 and row number 2. 50 cells are there. The battery supplies a current of 1 ampere. That means this current I is equals to 1 ampere to an electric lamp. This is your lamp. To an electric lamp having a resistance of 50 ohm. If the internal resistance of each cell has internal resistance 2 ohm. 2 ohm. So each cell has the internal resistance of 2 ohm. Find the EMF of cell. If we suppose EMF of cell as E, then we have to find E is equals to how much. Now here you see, here it is important to understand, in one row total EMF is NE because they are in series. So E plus E plus E up to 50. So 50 E is there. 50 E is there. If we suppose E as the EMF of identical cells, so 50 E is the EMF, and in parallel the EMF remains the same. So across this it will be 50 E only. You cannot add this one. This does not change. In parallel, the EMF does not change. What is the EMF of one row? That only remains the EMF. So, if we want to find the resistance of this row, we will be getting the resistance of 2 into 50, that is 100 ohm. And of this row, we are getting the internal resistance again as 100 ohm. So these 100 ohm and 100 ohm are in parallel. So if we want the internal resistance of the battery, it should be 100 ohm into 100 by 100 plus 100. That is 50 ohm. Now if we want the current should be equals to total EMF by total resistance. In total resistance, what I would like to tell you, that total resistance is internal resistance plus external resistance. So total EMF is your 50E and internal resistance is your 50 ohm. Total internal resistance is 50 ohm and plus external resistance, load resistance 50 ohm. So 50E plus 50 plus 50, that should be equals to I. And according to question, 1 ampere current is observed, a current of 1 ampere to an electric lamp. So this current is 1 ampere. So according to question, it is 1 ampere. So 50 E by 100 is equals to 1. That means E is equals to 100 by 50, that is 2 volt. So this 2 volt should be your answer. That has to be kept in mind. So see, different types of question I am trying to explain, which will support in understanding the concept that I have discussed in the series and parallel combination of cells. So these questions will help you in the clarity of the concept of that I have discussed in the theory section. In the discussion of the next question, here two cells with same EMF is given with different internal resistance. Its internal resistance, first cell internal resistance is R1 and second cell internal resistance is R2. Are connected in series to an external resistance R. Here is the external resistance R through which it is connected. Here the question is being asked, can a value of R be selected in such a way that potential difference across the first cell, this is your first cell, potential difference across the first cell should be 0. Now in this question, two cells are there. So what current we can expect? Cells are in series. So the current we can expect, total EMF E plus E by total resistance external plus total internal. So R plus R1 plus R2. Now if we talk about the potential difference across the first cell, potential difference, terminal potential difference, it should be E1 minus IR1. Why? Potential difference across first cell should be E1 minus IR1. This is E1. So E minus I is 2E by R plus R1 plus R2 into R1. So according to question, according to the requirement of the question, what is required? The potential difference should be 0. So this has been made 0. So ultimately E minus 2E by R plus R1 plus R2 into R1 is equals to 0. E we will take common and it will become 0. So ultimately R plus R1 plus R2 minus 2R1 is equals to 0. And this is giving us R plus R2 minus R1, because here R1 minus 2R1 is R2 minus R1. So R plus R2 minus R1 is equals to 0. So R is equals to R1 minus R2. That means if the value of this resistance becomes equals to R1 minus R2, then potential difference across the first cell will be 0. This is the requirement of the question, and this is a new type of question that you should understand in a proper way for better understanding of the combination of cells in series and parallel. So see it carefully. See how the potential difference across this cell is 0. Potential difference across first cell is 0 by suitably selecting the value of external resistance is equals to R1 minus R2. By suitably selecting the resistance, external resistance, R is equals to R1 minus R2. If this condition is satisfied, the potential difference across first cell is 0. Now in this question, now we should discuss this question, that when a resistance of 3 ohm is connected across the battery, the terminal potential difference was found to be 9 volt. Here is a battery, internal resistance is there, and here is the 3 ohm resistor ER. 3 ohm resistor is connected, and we are getting the terminal potential difference. Here we are getting 9 volt. If the resistance is changed by 4 ohm, the terminal potential difference increases to 10 volt. Now you see, the battery remains the same. So if the same battery is there, but this time I have changed the resistor by 4 ohm ER, it is becoming your potential difference becomes 10 volt. So you have to find E is equals to how much and R is equals to how much. Now in this situation, you see, I have supposed E the EMF and R the internal resistance. In first case, if we want to find the current, I is equals to terminal potential difference by total resistance. Total resistance is what? I is equals to terminal potential difference by resistance. So it is your 3 ampere, and that should be equals to total EMF by total resistance, that is E plus R plus R. This is R plus this R. This is your capital R. So we are getting E is equals to, this value is 3, so we are getting E is equals to 3R plus 9. This is the take is as the equation number 1. This is the first case. Second case, what I would like to tell you, in second case, this is the situation. In this situation, the current will be how much? Current will be, potential difference is 10 and resistance is R. So 10 by 4, 10 volt by 4 ampere, that means 4 ohm, that is 2.5 ampere. Now when this is this value, the same value of current is total EMF by total resistance. Total EMF is E and total resistance is R plus 4. R plus 4, this you are getting 2.5. This is the value, 2.5 ampere we are getting. So E into 2.5 R is equals to 10 ohm. This is one equation and this is your second equation. Simple equation is there. By solving these two equations, you will be getting the value of R to be 2 ohm and E to be 15 ohm. This is my homework. How? This is my homework, because it is already, you can solve these two equations. Simple 1 degree equation is there. Here, see the next question. In this question, the question is asking you, how do you arrange 20 cells each of 1.5 volt and internal resistance 1 ohm to give maximum current through an external resistance of 50 ohm, also find the current. Now here you see, I have discussed in the theory discussion that if n cells are there and m rows are there, then total number of cells, this is your m into n. So this is your total number of cells. This you have understood. So m into n is 20. Now remember the condition for mixed grouping, that for maximum current we have derived the relation R is equals to NR by M. That means MR is equals to NR. So here the value of external resistance is given 5 ohm. Value of external resistance is given 5 ohm. So 5 into M, and internal resistance is given 1 ohm. 1 ohm and 5 ohm. So 5m is equals to n. Solving these two relations, you can easily get m is equals to 2 and n is equals to 10. What does it mean? This way you have to take 10 cells and this type of 2 rows should be there. 2 rows should be there and each row should contain 10 cells. Then you will be able in getting the condition that is required by the question. So this thing also you should understand, this is based on the mixed grouping of your cells. Now see this question. In this question, the potential difference across the terminal of a battery is given to be 10 volt in the closed circuit. If the external resistance is increased by 1 ohm, the potential difference increases by 1 volt. So see, potential difference V is equals to IR, I is equals to E by total EMF by R plus R into R. So we are getting E by V is equals to R plus R by R, that is 1 plus R. Now according to question, in first situation the terminal potential difference is given to be 10 volt. So E by 10 is equals to 1 plus R by R. This is the first condition. If a further increase in external potential, if the external resistance is increased by 1 ohm, if the external increase is resistance by 1 ohm, a further increase in external potential difference, the potential difference increases by 1 volt. So here you see potential difference increases by 1 volt by increasing the resistance, and in the second condition it is given that if the resistance is increased by further 3, then potential difference increases by 2 volt. 2 volt is further increase in potential difference. So we are getting 3 equations. By solving these 3 simultaneous equations, you can get the value of E to be 19 volt and R to be 3.8 volt. So carefully read the question, and I hope that this much amount of question practice, if you will do, I certainly hope that it will build up your confidence and you will be comfortably facing the questions of series and parallel combination of cells in a very comfortable way. Have a nice day. Thank you.